Let's have a look at an example of a principle. Now, I tried to pick on something that was reasonably easy, people would understand easily enough without a whole lot of stuff. The problem is that I've got to try and fit this into a one single page slide, so it's easy to describe to you, and that limits what I can do. I also didn't have as much time as I'd like to go and thoroughly investigate all these principles. So let's pick on this one. Programmers evaluate their errors. Now, this was a principle that was proposed by Watts-Humphrey. And it simply says that programmers evaluate their errors. The implication is they investigate and solve their own problems. Right? You get a bug, you go find out what you did wrong. The description: programmers must investigate errors originating in software they wrote, determine the cause, correct the error, and demonstrate that the fix is effective. That's the principle as proposed by Watts-Humphrey. The benefits. Again, Watts-Humphrey claims that the benefits that by evaluating their own errors, programmers will learn and improve their work. Now that sounds quite reasonable. The other benefits are that the programmer doesn't suffer the public embarrassment of having their errors pointed out to them by someone else, or being told where they have deficiencies in their work. So investigating your own errors allows you to correct your own mistakes. Rationale. Evaluating their own errors allows programmers to broaden their understanding of how defects can occur, deepen their understanding of their own work habits, which is important, allow them to reflect on their programming understanding, allow them to discover and correct the cause of the error while avoiding public embarrassment. So that's the rationale for it. That they do it in the privacy of their own home, and nobody need know about it. So that's one way. Applicability. Now, the applicability of this is quite wide. All errors in code for which the authors remain present. All right. So all errors, all their own bugs. You get to fix all your own bugs. Now, evidence. There isn't so much evidence as assertions. Right? Watts-Humphrey, in Managing the Software Process, which is the book, it's the foundation of the CMM, and it's a fairly famous book. So he didn't provide evidence. There were no trials of whether this worked or not. There was simply an assertion that it did. He asserted that feedback enhances process improvement. Feedback includes defects, did result in better programs in 3 case studies. That's a paper there. But it was feedback in general. It wasn't specifically that programmers fix their own bugs. So we have a certain amount of support for it, and it sounds reasonable, but we don't actually have empirical evidence and definitive tests for this. Let's have a look at another principle, and that is the principle of independent review. Right? The description is that all work shall be reviewed by someone other than the author. Right? So you get an independent review of work. All work. Not just some work, all work. The benefits: an independent reviewer provides a test of reasonableness and correctness to the work. Okay? So we're assuming, and the assumption in there is that the reviewer is competent and capable of reviewing the work. They're not simply independent anybody who has no idea what they're doing and just checking the grammar and the English. It is somebody who is competent to review the work. The rationale. Independent reviewers start from a fresh perspective, so they're better able to detect false assumptions and overlooked errors. Okay? It happens all the time. If we work on something for 2 weeks or 2 months or something like that, we give it to an independent reviewer and they spot a mistake in the first paragraph. It happens all the time. Independent review is common practice in most professional domains because it's one of the most flexible practices. Now, for example, in accounting, accounting has the practice of audit, so that there is a review of whether the accounting was done correctly. In the legal profession, there is the principle of appeals, so the decision can be reviewed. How do we put it? I guess in software, there's quite a strong tradition of independent review, particularly of code. There's a less strong tradition of independent review of business case or business requirements, or the whole reasoning for the project in the first place. Nevertheless, it's there and can be done. Of all the verification and validation practices, independent review requires the least effort to set up. And that's important, because you don't need, it's easy to set up. It doesn't require tools. It doesn't require significant infrastructure to set up. So it's a very, very flexible practice. The applicability, all output. As the principle says, all work shall be reviewed. All output gets reviewed. Evidence. Now, there isn't a lot of empirical work supporting the basic principle of independent reviews. Instead, most of the information simply assumes that any type of review will find more defects than no review. Now, specifically, one of the papers I've got was by Sauer and Jeffrey. That's Chris Sauer and Jeffrey. I should know it because I know the guy. And in that, he simply stated it's assumed that any review will find more errors than no review. And that supposedly was a benefit. So there isn't a lot of evidence that of the benefits of review per se. There's a lot of research done on how reviews could be conducted or should be conducted, or the different ways of getting production out of it. So there is research in what makes a review more or less effective. There is research on different review processes in different contexts, and most of the research concentrates on code reviews, as opposed to, say, architecture reviews or requirements reviews or project reviews. The assumption with code reviews and the conclusions are that it's better to hold the review early in the process rather than later in the process. So that's the evidence we have for independent review. It would be nice to get more evidence, but there are two examples of software quality principles as expressed, and I'd like to see a great deal more of them.